Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. Now we'll write all these programs, everything. So step by step with execution I want to write right now. You can clearly check it out and get ready with the compiler. You also can execute the program step by step here. Yeah, I'm starting from a scratch with the empty text. So here I'm typing everything step by step. You can clearly observe. Of course, if your compiler won't understand some sort of the predefined functions, you can write as include stdio.h, but here it will take, but anyway I'm including it. Now I need to start first defining a node. How to define a node? I'll first write how we have defined in the single linked list. Alright, so what we have done there, we have taken a data part first, which is the data integer value, and where to in order to store the next address of a node. It's a node which is the address of the next. That's why again I have to take that next is not an integer, it's a completely a struct node. So struct node means you need to write hashtag next is address. What type it is it an integer exactly? No, it's a structure type. So which structure? Struct node. Of course this is also called as self-referential structure. So this is what we have written for single linked list. Now what extra you need to add? One more thing, which is previous node also you want to store it. So like this I'll take previous and next, two pointers. One pointer is for to get the next, one pointer is to store the previous. So when you write this one, you will get the answers. You will get like this. So here your a structure node will be defined, where this is the data part, this is the next address, this is a previous address, like this you made it. Now the next step, anyway initially the double linked list is empty, so that's why in order to make it I need to start with the head node, where head node value initially is equals to null. So head node equals null, that means you created a node, where it is a head node where the value initially null. So this is null means what? If this is null means your double linked list is empty. That means till now you didn't take any input. Now we need to give with the options. We have to start the main function, void main. Now might be the user. First I'll take the user choice. In order to get the choice of user, I'll take the variable integer choice. I'm reading from the user what choice he wants to give. Is it choice 1, 2, 3, 4 like this? And what are those choices? What it means by 1? I have to write prior. So what is meant by 1? Similar to the single linked list, I am writing printf. First thing, 1 for create, same like I am writing. 2 for we are writing insert node at beginning. Now 3 for displaying the nodes. And 4 for exit. And one more thing, display you can make it in reverse also. That also I'll make it step by step. As of now it is fine, and I will write 4 for exit coming out from the loop. Anyway, why we are writing exit, everything I explained in the single linked list. You can watch it, and again anyway I'll explain here also. Now we are asking the user give any one choice. You want to create, you want to insert at beginning, or display or something. I told you like create means creating a fresh linked list. Even the current linked list have empty means yes, you can start with this node. If there are already 5 nodes or 10 nodes, whatever the number of nodes, everything will be cleared, and in fresh you are creating a double linked list with the current node. So in order to make it, now according to the choice, we have to write switch case, which choice user wants to give. So switch ch, yeah, user might give the choices here. Case 1, how many cases are there? I'll write here. Case 2, as of now what we have written. Case 3, there is a space between case and number, of course it's a syntax part. Case 4, till now this is fine. Now what is case 1? Create a node, means that you need to enter a node value, so that according to that it will be created. enter a value. So that has to be read from the user. User will enter a value. So here like this, scanf %tld value means I'll give an input value val is a variable. So that variable also to be declared immediately. Anyway, break to be written once the, not here, break actually. Yeah, we need to give input the value which is a variable val. Once it is, what is the next step? Now you need to execute a function called as create. Till now we didn't define this create. Of course, with respect to the value, you have to create function to be executed, then break. So that means once a create function is done, yes, come out of this switch case. This is fine. Let us see first we can create the node or not. So it's a void. Why? Because not returning anything, simply creating with respect to given value. So create function with respect to a given value, something like same, I'll take x, that is whatever the actual parameter value is given. Let us suppose val value is 20, here x value is also 20. So something like this we can make it, and now we need to start. What is the point number 1? We just declared what is a structure declaration. We have made it in the first lines. Yes, here in the line number 2, 3, 4, 5, 6. So for that I need to create a node. Okay, now we just declared what is this type. It's a one new node, so I'll make it as nn. Okay, one node I need to create. What is that node to be created? Means it's an address, so that's why it's a pointer object. So we already created one node which is called as head node. Now we are creating struct node and new node which is pointer nn, where nn stores the address. Through that you can get the values of the node with respect to the pointer. I created a node struct node nn. What is the memory? What is the address of this node? Now you need to create through dynamic memory allocation. I am making it here. You can see malloc of how much size is needed. Malloc of, you need to get the size of the structure, size of what is it, struct node, how much size you need. Of course nn means it's, for example, in our example also we have written 100 to 111. So 100 to 111 means totally 12 bytes. How can I know? So nn is 100. Let us suppose how much you need, from how many bytes is needed for struct size node. What is node? So what actually this means? Anyway, we need to get typecasting here. Why? Because it's a struct node. Yeah. When you write this statement, it means that whenever nn is equals to 100 means it starts from 100. So malloc of memory allocation can be done. How many bytes? Struct node, how much size for the struct node? Yes, you can see struct node consists data part and previous and next address. For all these three integers, totally 12 bytes. So that can be explained, that can be given by this line, which is nn equals to. Now once you declared, once you have written this, that means this nn node is created with respect to memory. But what are the inside values? Till now you didn't give, right? So I am giving the values. You can see first thing, what is the data inside? Data inside is whatever the user given value. What is the given value? The value is x. So nn of data equals to what is the value? X. What is nn of previous? Till now you didn't connect to anything. So nn of previous equals to null. So nn of next, of course it is also null. Nn of next, of course it is also null. Why? Because we didn't connect to any node till now. So you can see if I write this statement means, yes, what is x value? Here x value will be there. Here it is null and here it is null. Now you created a double linked list node as of now. Now this node, whenever you want to create, you need to connect to the head node, right? What is the value in the head node? Null. Now this head node value should become what? This nn value, so that it will be connected like this. That means if you write head is equals to nn, means what? What is nn? Might be some address 100. So 100 you need to write here, so that it is connected. So head node, whatever the address it is consisting, means that the node with that address will be the first node in the linked list. So here 100 it is there, so that's why this is the first node. If there is another node with the 200, if here it is there 200 head value, then that node will be your first node. So the same thing here, with 100 it is the first node we created. Now simply created, so we need to connect. Till now we didn't connect. How to connect? Head is equals to nn, if you write absolutely over where you connect it simply. So this is what I told you, like when create means even n number of nodes are there in the linked list, which everything will be erased, and in fresh it will create the what you call it as double linked list with this node which is nn. So simply it will create the node. That is about how to create the node. Anyway, I don't want to display as of now. We'll have one more functions after that display, then I'll show everything with execution. Now let us suppose I want to insert a node at the beginning. It is already existing a node. Of course here it is null. This is existing. Now I want to insert a node at the beginning. So what changes I need to do? This is a node nn. First thing, I'll write the function, you can see. So it's a option 2, which is case 2. Of course again you need to give a value. So I'll copy here this case 1 statements, I'll copy and I'll write here. Of course I'll modify here. Anyway, you need the value val, and here instead of create function I'll make it insert underscore begin. The function name I'm writing insert underscore begin, which has to be executed. Let us suppose I'll go for here insert underscore begin. The function I'm writing here void insert underscore begin, where you can see the value which is int x has to be given. The value whatever is given, the value according to that which we have to make it. Anyway, the same thing here till now it is. Why? Because you need to create a node and you need to initialize with x and the value, and previous and next is null. So I'm making here, you can see I just copied whatever. That means whatever I have done here, it means that so we created a node here. Now after this, when you create a node, it will be like this. So null here and null here. Now the thing you need to observe, this node should be the first node. What changes you need to do? That means you can see first thing, this address, anyway the next address of this nn of next should become, what is that, this address 100, which is a head node address. As of now it is stored in head node. The first statement you need to write so that it will become 100. So it is connected like this. Anyway, this connection to be removed. How to remove this connection means, here instead of 100 you need to have 200 here. That also we'll see. So in order to connect this one, head node value should become what? nn, which is new node address. Now is it fine? No, you can say this is the first node, previous is null, absolutely fine. Next node is 100, this is fine. But here you can see for this node, this is now second node, where the next, this is the last node actually as of now, null is fine. But here instead of null, what it should be? It should be the current node address. Is that right? So that is what, how you can make it, where this address is there. So that means before updating this head, of course head if you update immediately, this will become whatever the current address. If it is 200, it will be 200, sorry, here it will be 200. So this 200 will be there. So where we cannot get the address of this one, or else if you want to write, you can write nn of next, then previous, like this you need to write. So instead of that, before updating head of previous, now I'll make it with nn. So what happens? Head value 100 to the previous nn means the current node address, which is 200. Now head equals to nn, then it will become 200. So I think these three statements are absolutely fine when you want to write insert node at beginning. Now again I have to check here one more thing, that is if head equals null means you are inserting the node at the beginning, but still that linked list is empty. What you need to do, if head is equals to null means what? So there are no nodes in the linked list. Yes, when there are no nodes in the linked list, even if you write insert at begin means it simply has to insert the node at the beginning, which is create function. So simply I want to execute create function with the same value. So it will execute create function where this is a function will be executed. So this is a one thing you can do. here if head equals null. If not, if it is not null means there exists some nodes. So then how can I go means here else part I have to write yes if there exists. So I told you what are the things you need to do. NN of next, first you need to make it is null to update it as what is the head node current value. Why? Because the current node it is there at the beginning which will become the next node, and the current which you are taking which will be the first node. Now NN of next equals to head, and head of previous which has to be updated I have written there. Head of previous is equals to NN, and now update what is head. Head is equals to NN. So this is what simply you need to construct like this so that you can easily get the answers. And one more thing we need to remember, here we are maintaining only head node. In order to get the what you called as optimized answer, complexity to be reduced, you maintain not only head node, you maintain the tail node also. That is also I am taking here, where if initially there are no nodes, fine, when you create head equals to tail equals to, both will become the same node, right? If you have only one node exists, let us suppose in our first example this is the head node and this is the tail node, but when you insert this one at the beginning, this will become head and tail is not updated, right? So this is what you can do. So head is the thing which always to be updated when you insert at the beginning, where tail won't be updated. Tail will be updated when you want to insert at the end. So I think this is a very fine, and we can write these three statements. With the complexity one there is no loop. This is absolutely fine. So now insert at beginning is over. Let us see how the display part, so that will display whether we have written it correct or not. So the third one display part, how the display can be written. Yes, I am writing here directly the display, no need of any parameters for this. So display part and then break once the display is over. So what is this display function? Let us see here how to display, and I'll write here void display. Then I'm writing here, see, if there are n number of nodes, I'm writing here this display is a common as same linked list which we have done already. So this is head node 100, here 10, let us suppose this is 200, this one, and this 20. Previous node address is 100, this is 300. Connect like this, and here might be something 30. Previous node address is 200. So I'll start a temp variable which is starting with the head node. Temp variable starting with the head node, and it will go next until you will get the null value or till the tail value. Anyway, tail is at the last, right? So this is tail at the last. So until head is equals to the tail, or head is equals to the tail of next, whatever, head of next, that is temp of next, sorry. While temp is equals to the tail means it should not come out. In that case you will lose the last node. So temp should go till the null. So here I am writing, I am taking a struct node temp, where temp is initially head node or null, whatever, both reflects the same. We'll take the struct node temp, where temp is initialized with the head node which is the first node of the linked list, double linked list, and I need to traverse it. And again here also I'll make the if condition, if head is equals to null. What is the meaning? That list is empty. So that's what we need to print it. Printf, the list is empty. So if not, else part I'm going, it's not empty, then we need to traverse it. I'm traversing here, you can see. Else, of course, I need to write a while loop to get each and everything. While temp is not equals to null. It is similar to our single linked list, how to traverse. While temp is not equals to null, you want to printf %ld. I'm writing, of course, like this, just a representation, %ld, which is temp of data. This array is nothing much, like just to represent one node to the another node with a gap. That's it. Temp of data. Once you have taken the temp of data, temp has to be updated with temp of next. So like this you can make it. temp equals temp of next. It will go every time and it will execute, and you can get the display part. So as of now we have taken what just those who are executing, you can see. Anyway, I'll execute first, after that I'll show entire program. Yeah, as of now we created a double linked list structure. So for that we have created 4 nodes, I mean 4 options which with the choices. So choice 1 means create, choice 2 means insert at beginning, choice 3 means display, choice 4 means exit, coming out. Let us suppose we basically will make it like this, exit of 0. Now let us see, one thing is missing here inside, that is a while you have to write. Why we need to write while? Let us see. Anyway, I'll execute it first. Yeah, one thing we missed here, struct node pointer head equals null. This is, and here there is no comma. See, like this you need to rectify the errors. Head equals tail node, did you create as of now? Let us see, struct head equals null, but you didn't create. So tail also equals to null. You have to write initially. Now let us see more errors. Yes, no, right? But what anyway, you won't get the perfect output here. Anyway, if I give option 1, means it will create a node 30, but the process is ended, but I don't want to end the process. I want to give again enter your option like this, right? So that is what it's not happening here. That's why we need to write a loop here for this printf statements. So that's why while 1 means, anyway, whenever while 1 means it goes infinite, but when you write exit here, so when you give case 4 means it is exit. And also one more thing, if you want, it's optional, but if you want to write, you can write enter your choice printf. You can write here enter your choice. I think that is fine. Let us see the output here. Yeah, every time enter your choice here. See, initially I'll go for display, where what is the display? Nothing is there, so that's why linked list is empty. Now enter your choice, I want to enter 1 to create a node with respect to that. First 20, let us see the display part. Yes, 20 is there. Now I'll give insert node at beginning to option 2, enter a value. So I'll give option, I mean the value is 10. Now the display should be, you entered at a starting, so 1020 it should be. It's not 2010, it's a 1020. So option 3 you can see, yes, 10 followed by 20, like this you have here. Now again I want to insert one more node, option 2, maybe 30 at the beginning. Now the answer should be 30 10 20. You can see the display part, 30 20 10. So like this. And next you can insert one more if you want. Yes, I'll go for 40 at the starting. Yes, just see the display part like this. Now you may think like there is a flexibility in the double linked list where you can display the elements in the reverse order. So for example, in this case 40 30 10 20, I want to display in the reverse order, means 20 10 30 40 it should be. How can you make it? So that is what I can do now. One more function I'll execute here, which is display in reverse. So that is also I'll write here printf. I'll write option 5, display in reverse. How to write this? This is quite easy. Why? Because we are at not only the front, you can go back and you can get it. I'll explain here, you can see. So case 5 I'll write. So the function name is display underscore reverse, then break like this. Now I want to implement it. Here you can see void display underscore reverse. Now for this, how to get this display part? Now let us suppose this is 100, this is 200, this is 300, this is 100 here. Anyway, here it is 200. This is null. This is 100, which is a previous node. This is 200. This is 200, which is a previous node, and here it is null. Now I want to display in reverse means this is a head node, this is a tail node. Now when you want to display in the straight order, so you started from head node and you printed every time going to the temp value to the temp of next. But here when you want to display in reverse, you start from tail, you come back. How to come back? So here temp is initialized to tail and you come back. How to come back? Temp is equals to, previously you went to the next, now you come to the previous node. So there is a flexibility, right? In the double linked list you can come back also. So that is a very simple one, you can make it here. And anyway, this part is absolutely fine, but you can say I'm copying actually. Where it is a change, I'll try to make it so that you can easily understand. I'm copying, which is the display part I'm copying, so that what modifications you can do here. Yeah, first thing, temp should start with head. No, it should start with tail node first. Now if the head equals null, it's fine, right? Empty linked list. Head is fine or tail is also fine. Tail is also null. Any one is fine. Fine, you can make it, no need to change it. Else, then while temp is not equals null, you print the data. Anyway, you print the data, temp of data, then you don't go to the next. You have to come back. You started from the last, you are coming back. It's something like, see, if you go for display means I equals 0, I equals 0 means temp equals to head. We'll write I plus plus means temp equals temp of next. Okay, I less than n going to the last, temp is not equals null. Printing a of I in the arrays, temp of data. So that is what printing in the straight order, forward. Backward in reverse order, you can see I equals, will write n minus 1, which is tail node, temp equals tail. So I greater than or equals 0. So while temp is not equals to null, coming back to the original here in the last node. And printf temp of data, which is a of I. Now I minus minus you write, so that's why temp of previous. I plus plus means temp of next, I minus minus means temp of previous. I think that's it. Let us see this one also, whether we'll get the correct output or not. Once it is executed, I'll give the complete view of the code, so those who are executing, they can execute clearly. So I'll execute this one. Initially the display list is empty. I want to create the nodes, enter a value 20. So I'll go for the display, only 20 is there. Now option 2, 40 I'll give. The answer should be 40, 20. Now again option 2, 60. So the display is 60, 40, 20. One more node I'll take, 70. The display part is 70, 60, 40, 20. One more last node I'll give 10, like this. So the answer is, the display part is, you can see 10, 70, 60, 40, 20. So this is the display in the first to the last node. Now reverse, option 5. Let us see, if I give option 5, it should be 20, 40, 60, 70, 10. You can see the answer 20, 40, 60, 70, 10. So like this easily you can get it if you want to get the reverse order, especially in the case of double linked list. So this is the main advantage compared with the single linked list. Now those who are executing, they can clearly check it out, the program, and see if you get any errors. I'm scrolling down. You can pause the video wherever you want. Now we are done with create a node, insert node at beginning, display in reverse. We'll see the next functions in the next video lecture. Thank you.